In this movie, I want to consider damping and quaternion spherical interpolation. So what I have open here in front of me is the rotation scene, which you can find in the course companion files under Scenes Rotation. And we've seen a similar scene before. This is a scene that contains primarily two objects, a capsule object and a target object. And if I press play on the toolbar and I move around the target, we have this target that turns to look, we have this capsule rather, that turns to look at the target. So let me just zoom in just a little bit. And if I move my target object, the sphere here, you can see that this capsule is turning to face that sphere wherever it goes. Now, this is often a very useful behavior, but notice that there is something wrong with this. If I move this sphere over here, this does indeed turn to face the sphere. But very often characters in games, like gun turrets for example, they not only catch up to focus on the object they are facing at, but as they stop rotating, they gradually come to a stop. Their speed gradually declines, so they don't stop suddenly, they don't stop immediately, but they come to a stop gradually. And one of the ways that we can achieve this effect is by using damping. Or rather, damping is the effect of this slowing down and catching up over time. And to achieve it, we are going to use Quaternion spherical interpolation. Now, I've already gone ahead and added that code, and I want to show you how we can activate it and use it. So I'm going to press stop on the toolbar here and move down to the project panel and show you this rotate to script. Now I'm going to double click on that script to open this inside MonoDevelop, and you can see what's going on here. In the update function, we are currently calling the rotate towards function, and we've seen this before. What happens is we are using the Quaternion look rotation function to retrieve the quaternion, that is the destination quaternion, the quaternion that represents the rotation in which the capsule is fully looking at the target. And then we use the rotate towards function to transform or rotate the quaternion from our current rotation to the destination at a particular speed. But I'm going to completely deactivate the rotate towards function. I'm no longer going to call that. Instead, I'm going to, inside the update, make a call to the rotate towards with damp. This is another version of this function, so this is just a separate version of the rotate towards function, but this function implements damping. So I'm going to copy this code and I'm going to call it inside update and press Ctrl S on the keyboard. I will come back to this code and explain it shortly, but I'm just going to minimize MonoDevelop and I'm going to press play on the toolbar. And when I do it this time, we can see that we get quite a different behavior. We can see that the object rotates to face the destination, but as it does so, it not only catches up, but when it comes to a standstill, it gradually stops over time as opposed to coming to an immediate stop, and things are looking much smoother and more realistic. So I'm going to press stop on the play bar and go back to the rotate script here just to bring that into view. So we're doing a very similar thing to the rotate towards function. We are using Quaternion look rotation in order to calculate the destination rotation, the final rotation that we should reach in order to be looking at the target. But whereas previously we used rotate towards, we are now using Quaternion.Slerp, which stands for spherical interpolation. This is the process of gradually coming to a destination over time. We are simply taking our current rotation and our destination rotation, and then we are plugging in this value based on our damping speed in order to gradually change from one quaternion to the destination one over time. And what the slurping effectively means is that when this value is 0, we are going to be fully using this rotation vector or rotation quaternion. When this value is 1, we're going to be using the destination rotation instead, because 1 means we have reached our destination. And any values or fractional values between this slurp function is going to smoothly interpolate between the two quaternions over time. And finally, when we get our smooth result out, we simply assign that to the rotation of the object as we are doing here. So I'm just going to exit this code and one last time press play on the toolbar to admire the results of our handiwork here. So I'm going to move this object and it smoothly rotates to face it. And everything's looking nice and smooth. And this is a really great effect that I recommend you use to create, for example, gun turrets that have to face the player. But this is not the only place. It could be spaceships, it could be enemy characters. The possibilities are endless, but the effect really is quite impressive.